Hi there, welcome to End-to-End Solution Architect session. Today I will be talking about AWS CodePipeline with Terraform. So we will be writing Terraform script to provision a complete AWS code pipeline with code build and code deploy, which will pull code from Git repository and will finally trigger a separate Terraform code which will provision an EC2 instance. So let me show you the architecture. So here is the architecture that as a developer you will trigger the Terraform code which will pull the source code from GitHub repository and will create this AWS code pipeline, complete code pipeline, and will create an EC2 instance. Now, when we are creating this pipeline, during multiple phases, it will pull the Terraform image from Docker Hub, then it will initialize and perform apply to provision this EC2 instance. Now let me show you how it works actually. I am logged into my AWS console. Let me show you the EC2 and code pipeline, that do you have any pipeline already created or not. Here it will show the listed pipeline. Currently we don't have any pipeline over here. That's fine. And in EC2 you will find that what are the running instances. Now let's go back to our Terraform code and let me show you that how we should be able to write the script. Now in my Terraform code I have created a my project repository, okay, and I have standard few files. If you are following my advanced Terraform series, then you must be knowing then what are the purpose for this file and why I do use it. Well, so now in main file I will be writing all the modules or the resources we require. Now in my previous session I have explained that how we can write modules, what is the purpose for modules, and how module is helpful. Now in this session I will be using modules instead of coding the modules in the project itself. Well, so let me first define the tags which I will basically want with all the AWS resources I will be creating. And this is a very good practice that when you create any cloud resources, you should put the tag. At least these two tags, which is saying project, what is the project name, and created by. And I do mention the created on as well. So one is created by and created on. And in this case, I am adding this environment, which is pulling from Terraform workspace. What is the workspace I am using? Now in my past session I have explained the Terraform workspace and how you can handle multiple environments, like you have dev environment, integration environment, stage, production, and how you can manage all those environments together. Well, so I have defined this tags with local. Now I am just copying the modules which I will be using over here. So here is the code build module. The first thing is that when we create a code pipeline, we need a code build as well. Okay, so first I am defining a module called code build, and let me show you the module actually where it is. You will get the complete code of this session, so you do not need to worry about that. Just focus on how it is structured and how it is functioning. And let me show you that where you will get this code. So if you go to, I will share this link in the video description. If you go to E2E Solution Architect /Terraform, and you will find all these codes and tutorials, projects, modules, technical docs, and KDB over here. Well, so let me go back. Well, so here is the code build module we will be using, and you see that I am using the local source format. If you are pulling your module from your Git repository, you use the URL format like this. I have explained in my past session I am not going into that again. But we have this code build. Now let me show you how this code build module is defined. So here in this left side you see that we have this code build module, and again this you will find this code build module in the Git repository link I will be sharing. You will find it the Terraform under Terraform modules. So for now here you see that we have the required resources created for code build over here. So first one is the AWS code build project with name, description, service role, environment variables, and logs config we have mentioned. Now the one of the important part of this code build is that where it will get the source. So currently we are using the Git repository, so we have to define the type, location, Git clone, report, and build spec basically. Now let me show you what I am meaning by this build spec. Build spec is something you provide in your code build which says that what are the instructions it has to follow. Well, so the instruction basically in our case is that we initiate Terraform and then execute. So this build spec is inside our code pipeline project. So let me show you. I have two build spec files here. One is for plan, another is for apply. And in apply it says that the phases, the first phase which is pre-build, it does Terraform init and then Terraform validate, and the next phase is called build, which is basically execute Terraform by applying execute, which is basically Terraform apply, and it is the standard command I use as best practice. Okay, now let me go back to our project portion again. So here we have drafted our code build module. Now let's create our module for code pipeline. So here I am adding the module for code pipeline again, and you have seen that again I have mentioned the source from the local and the project name S3 bucket full repository ID. I will show you how we are providing this full repository ID. And let me emphasize this part which talks about the code start connector credential, and this is what we have to provide in our variable file. So let me take you to AWS console. Here is the code pipeline, and on the left side panel go under settings, go to connection. It will list all the connections you currently have, then create connection. You will have three options to select a provider, and we are selecting GitHub because we are keeping our source code in GitHub. Now give a connection name, suppose test connection. Tags optional, but I do recommend when you adding the tag. I will not be creating this connection because I have the connection already created, but let me show you how you can create the connection. So click on the connect to GitHub. Now on the screen it will ask you to select the GitHub apps. If you are doing for the first time, you may not have the apps already listed. Apps are basically the connections when you created, the new apps are created that time. So you click on install a new app and it will take you to the GitHub page, will list your users, and then you grant access to AWS. I am not taking it to the next level because I have my connections already created, but I showed you the steps that when you are doing it for the first time, you create the code start connection like this. Now let me go back. Well, here we are back again. Now let me show you the code pipeline module. Well, I am going to the under modules. As you see that it says that modules, then it is E2ESA module AWS code pipeline. So I am going over here on the left side panel, and here is my module. So I am opening the module in a side panel, and it's showing that the code pipeline, the normal with the name, role ARN, it is the IAM role we are providing. Then the stages, we have defined multiple stages over here. Now our first stage is source. So it will pull the source from the GitHub, and the next stage is I have made it apply, because in when you are executing Terraform, it is basically that you initialize Terraform and you plan and then apply. Now if you directly do apply as well, then it does the validation, planning, and then the execution. So I am directly calling apply. Now you may be thinking that why we are not using the plan part. The reason is why here in this session why we are not using plan part, because it will not add any value, because we are not using manual approval. So basically what happens, that when you want to approve, so you check the plan, what the resources are going to be created, you check that plan output and you approve that, and the next stage is apply, which gets executed after your manual approval. But we made it very simple, that we have the source code for the first stage. It will pull from the GitHub repository and will simply do the Terraform apply. But in your case, when you are using it in your organization, you may use the source and then you create a stage for plan. After plan, you do a manual approval, and then ultimately you create a stage for apply. Now in this session I am showing you very simply this source and this apply part, but maybe when you are watching this session, you will find the upgraded script having that manual approval and Terraform plan part as well. Okay, so let me again go back to our project part where we have defined. Now what we have to do, that we have to define the variables. So all the variables we have used over here, we have to define it in a variables.tf. So I am just copying all the variables together what we are required to provide for these projects, and you see that we are providing these tags, general variables, then this list of code build variables, and these three are for code pipelines. So let me save that. And the last one, which is basically the first thing we used to do, so it is the version we are mapping, that what is the Terraform required version and the provider we are using. In this case we are using AWS as Terraform provider, so I have mentioned over here setting the profile also, and we are using Terraform 1.2.0 or greater version over here, and here is the Terraform required providers configure. So we save that. So what we have currently, we have this version created, we have variables created, we have the output part. Let me take you to the output, and we are simply creating two outputs. We want to show that when the pipeline gets created, let's flush out the code pipeline here and code build project here, these two parts only. Okay, now we have our main, which is the modules are created, and we have one variable files which is dev.app.tf words, and here we usually provide all the key value pairs of the variables we are using. So here I am adding the list of variables we need. So as you see that we have provided our project name, project description, environment, compute type, environment image, and here is the HashiCorp Terraform 1.2.2. This is the image we are actually pulling from Docker Hub. So let me show you the Docker Hub for HashiCorp. So simply go open a browser and open Google. So it will take you to the hub.docker.com. I'm just opening it over here. And here you have the Docker pull HashiCorp/Terraform. Now we have particularly mentioned the which version we required, that is 1.2.1. That's why the format is like this. But if you use this HashiCorp.Terraform, it will basically take the latest version of Terraform. Otherwise, you can go to tags and you can find the particular version you want. So you see that we have lot of versions over here, 1.2.3, 1.3.0 alpha, like this. Okay, now let's go back to our variable files, and we have this Docker Hub credentials, but we are currently not using it. The credential provider also not using it, but maybe when you are watching this session, you may find in code that we have upgraded this code with the credential provider secrets manager we are using. Now we have mentioned few environment variables as well. So these are the environment variables we want to create for our code pipeline. Code bale, which is a key value plain text, which I have just drafted with the name, that when you are basically passing some key value pair, then how you can pass for your environment variable. Okay, and we have this build status source version. It is basically the name of the branch. If you are creating any new Git repository, you may find it as main, M-A-I-N, not the master one. Okay, so it is the build spec file absolute path. So here I have the build spec file which is in my local repository, and I have showed this build spec file from here for my another project directory. So let me copy this build spec. So I copy this build spec and pasting it my project repository, and here I have my build spec, and I have the apply build spec and plan build spec. But as I said that we are not using the planned build spec, we are using directly the apply build spec, because we are doing this directly Terraform apply. When you are creating a stage for plan, then you use the plan build spec for plan stage and apply build spec for apply stage. Okay, we have mentioned in this variable file this only the placeholder for this VPC ID, subnets, like, and security groups ID, but these three things we are not using. Now let me take you to a architecture that why we are not using this. As you see in this architecture, you have a central account and you have a workload account. Basically, when you are working in your organization, the structure is like this. Okay, your DevOps, everything is created in a separate account, and your resources are provisioned in a workload account, which is a complete separate. Now if your applications are deployed, or your whole code pipeline is deployed in a private subnet, as you see this is a private subnet, we have our code build over here, then basically you need the VPC configuration when you are creating the code pipeline. Okay, but when you are creating that code pipeline with VPC configuration, you need little bit more resources and the configuration to set up the code pipeline. So in that case, you will need a NAT gateway in a public subnet, which will basically provide the connections to your private subnet, because you basically need to pull the Docker Hub image through the public internet. Then you have your secret manager where you are keeping your credentials. You will have your CloudWatch to monitor the logs. You definitely have your code pipeline and the code deploy, and the S3 bucket, whether you are using to keep your code or you are using for your logs. And ultimately it will provision a resource in a separate workload account. Okay, so our VPC configurations are required only when you are setting up your code pipeline in a private network. Okay, so let me go back to our project directory once again. So here we are in our dev-app.tf verse, and that's the reason we are not using this VPC subnet and security groups in this session. Now here is the source location, so the source code. So let me take you to the source location, where is basically it is. So if you go to the Git repository of E2E Solution Architect, you will find a TF code pipeline repository, and here we have the source code. And source code for what? It is to create that EC2 instance. So it is not the code pipeline source code, because code pipeline source code is already in your local system and you are going to execute that. This code pipeline, when it will be provisioned, your first stage, which is source, it will pull the source code of this TF code line repository, and which has a module defined called EC2 to create an EC2 instance. Okay, so if I take you to the design once again, as here you can see that we are currently have one single account, the central account, and here we have the code pipeline which we are setting up without VPC configuration, and in this same account we are creating a resource which is a simple EC2 instance. Okay, now this code pipeline part and pulling the Terraform image, instantiating that and performing Terraform apply, this is one set of code which we are writing in this session. And once the code build will trigger, it will basically pull a code from GitHub repository to create this resource. Let me take you once again over here. So this is the code for the EC2 part. Okay, so now we are almost done with this. That we have our dev-app.tf also created. Now let me take you here. Well, now let's execute this. Now first thing is that we have to do this Terraform init. Terraform has been successfully initialized. Now let me clear the screen and let's run directly Terraform apply. And you see that I am passing a variable file, our dev-app.tf because we have all the variables key value pairs in this tf files, and I am also passing a variable called created by, basically who is running this command. It is as part of the best practice, and this created by will be added with the resource tag over here. Okay, let me remove this auto approve. Let me do this, enter. So it's saying that it is going to create 9 resources, and you see that everything worked well, means the plan worked well. So now it is asking for the approval, and let me approve that, and it has started creating code build, code pipeline, both the modules from here. Now let me take you to the AWS console. Here is our pipeline. Let me refresh that, and you see that the pipeline has been created and it's showing the most recent execution in progress. So click over the pipeline. The source successfully executed. This is the part, and we had 2 stages. One was source, another was apply. So it is now executing the apply part. It will take few minutes. You can click the details over here if you want to see that the progress. So let me take you to this, and it has started executing. It is showing in progress but has not started showing the build logs over here. So it will take a minute, and it has started showing the build logs over here. As you see, started pre-build. Okay, Terraform plan started. Basically when you initiate the Terraform apply, it shows the plan as well. It has created 4 resources. 4 resources means basically the EC2 instance code which is being created. It is showing that, and this is the output part. So this is the time. Now we go to our EC2 instance and click on refresh. So let me remove this filter running because it may be just initiating. Okay, it has started running over here. So you see that this is the new instance. It has been created, and let me take you to the code build log once again. So you see that what are the things it has created. So it is going to create the EBS volume, EC2 instance, the CloudWatch matrix, the volume attachment and all this. So it has created these things. EBS volume it has created, and then EC2 instance also it has created, and EC2 instance ID which is ending with CBD. So let's go here, CBD. So this is the instance it has created, and along with this instance I have also created the volume to attach with this EC2 instance. So I am just clicking over the volume, and you see that we have two volumes created. Okay, the reason of two volumes is that in our EC2 module I wanted that to attach one separate volumes as well, EVS volume. And if I go to the CloudWatch, it should have created one alarm for EC2. So let me show you that. Well, this is the alarm has been created. Let me go to the all alarms. On the left side panel, click on the click on all alarm, and you see that this CPU utilization alarm has been created. Currently it has insufficient data because the EC2 instance has just been initialized. Okay, and this alarm will trigger when the CPU initialization is greater than equal to 80. Okay, so no problem, I am not focusing on that because you have learned that how you can create the code pipeline, and through code pipeline how you can trigger your another Terraform code to provision any set of resources. In this session I have showed you that you create EC2 instance, attach the EVS volume, and create the alarm for CloudWatch as well, but you can do any resources. Okay, so basically this is the way you can automate your code pipeline and automate any resource provisioning. Hope you have understood this session well. If you have any queries, please write in the comment box and I will be happy to help you. Now before closing this session, let me take you to the next session agenda, what we are going to cover. So in our next session, we are going to cover about a complete automation of AWS ECS workload. So we will write Terraform script and I will show you how you can automate AWS ECS workload just by a single click. If you want to know more about our forum, which is e2esolutionarchitect.com, please visit the site or email us at info@e2esolutionarchitect.com. See you in our next session. Thank you for your time.